we'll still continue on the video with algebraic expression, and today we are going to be dealing with the addition and subtraction. So how can we add and subtract algebraic expression? Now, before going to any example, there are rules you must understand in algebraic expression. One of the rules state that whenever we want to add or subtract any algebraic expression, we must note that only what like term can be added or subtracted to a given single term. This is sometimes called collecting like term. So in other words, we first collect like term. So what then is a like term? When we say like term in mathematics or in algebraic expression, it simply means that terms that have the same variable raised to the same power. Now, for example, let's say, let me give you this expression. Let's say we have 5x plus 4y minus 4 plus 3x minus 2y plus 3. So this is the expression. So how can we collect like term here? Remember, they say like term are terms that have the same variable raised to the same power. So if you can see here, 5x is the same, or it's like to 3x, and okay, that's a 2 like term for the x part. So these two, they are like term because when you are, this is 5x plus 3x, so these are like term. And also we have here plus 4y minus 2y. These are also like term. I'll further explain. And we also have here minus 4 plus 3. These are also like term. So now you can see from this first set, this other set, and the second set, the third set, you can see the difference. What makes this one becomes like term? We have here x and we have here x, irrespective of the coefficient in front of the variable. As long as the variable are the same, variables are letters, as long as the letters are the same, irrespective of the number in front of them. So you can collect this variable as 1 before you further do your expression. And also the second aspect, we can see here 4y, this is y, and this is y. Irrespective of the coefficient in front of the variable, as long as they are the same variable, you can class them as what? Like term. And we also have here minus 4 plus 3. Of course, they are also alike because these are two constants. Minus 4 plus 3. Minus 4 does not have any variables, and plus 3 does not have any variables, so you can call this again like term. So this whole process is what is known as collecting like term. Collecting like term. So once you collect like term, grouping them together, and you can further your expression. So let's proceed. Let's say now we have 5x plus 3x. So this actually what? 8x, and plus 4y minus 2y. This actually plus 2y minus 4 plus 3. This is actually minus 1. So this is the expression. So this is what is meant by like term. This is what is meant by collecting like term. You group them together, letters to letters, and constant to constant, irrespective of the coefficient in front of the variables. So this is what we know as like term. And let's understand also the addition aspect. So for this one, why do we say this is 8y? Yes, we have here 5x plus 3x. Remember, we have here x, this is x. Oh, sorry. So we have here x and this is x. So on the two terms, we have the same letter, but different coefficient. So in addition, under algebraic expression, you're actually going to add the two coefficients. If there is any power, let's say we have here power 1 and power 1. Okay, this one is more applicable in the multiplication aspect. So you add the two coefficients. So the two coefficients here are what? We have 5 and 3. So if you have 5 plus 3 and you just take one of the variable, which is x, this will give you 8x. That's why we have 8x. And also for this other one again, we have here plus 4y minus 2y. You can also note that we have y here, but the coefficients are different. So what you do, you add or subtract the two coefficients and just take one of the variable. It gives you the final answer. So if we do the same thing again here, this is the coefficients. The first coefficients plus 4 and the other coefficients minus 2, but they are sharing the same variable. So we say plus 4 minus 2, and what are they sharing? Y. So plus 4 minus 2. Remember, the bigger number carry the sign. So this is obviously 2y. So that's why we have 2y. Understood? And for this one, it is a very simple mathematics. I don't want to go in again on this other side. This is minus 4 plus 3. This is very simple. The bigger number carry the sign, right? So this is actually minus 1. Minus 1. So that's why we have the answer to be 8x plus 2y minus 1. So this is a very, very simple form of addition and subtraction in algebraic expression. So I'll be giving you more example for you to try. Okay, let's take another example. Let's say again we have another example. Let's say we have 4x plus 2y plus 3x plus 5y. So how can you go about this again? It's simple. Just follow the first step, the previous step earlier. What we do is we first of all collect like term. Like term. Remember I said like term must be of the same variable irrespective of the different coefficient. So let's collect the like term here. So we can see that we have here 4x, and let me change this color, 4x and then plus 3x. Their like term we also have plus 2y plus 5y. These are also like term. So what we do, we take one of the variable and add the two coefficients. So the two coefficients here are what? For this first set, we have 4 plus 3, and what are they sharing? X. And this other one, we also have plus 2 plus 5, and what are they sharing? Y. So this, the answer now could be 4 plus 3, this is 7x, and plus 2 plus 5, this is what? Plus 7y. So this is the simplest expression we can go to. So this is the simplest expression we can go to. And so let me give you some exercise, and you can do the at your own pace. Let's take the first exercise here. Let's say exercise we have x square plus x plus 2x square, and the second one is 4x square y plus 5x y square plus 3x square y minus 2x y square. So do these two exercises. In our next video, I'll be solving them before we proceed to the next level. Thank you. I'm Kalawa, and this is Made Simple with us. Follow us on our TikTok and subscribe to our YouTube channel. Thank you.